Let's say that I am standing on the back of a pickup truck that is not moving, and I am throwing apples forwards. I know that I can throw an apple at exactly 15 meters per second every time. If a person were standing on the sidewalk, how fast would she say that the apples are moving? So remember, I throw at 15 meters per second. She's standing off to the side watching this. Okay. She would also agree that the apples are moving at 15 meters per second at this point, because we both have the same frame of reference. But now let's say the truck starts to move. It's moving forwards at 20 meters per second, and I am still throwing apples forwards exactly the same as I was before at 15 meters per second. If I'm not really paying attention to what's going on around me, like the fact that I'm standing in the back of a moving truck, how fast would I say the apples are moving? Well, I would still say they're moving at 15 meters per second. But what about the girl on the sidewalk, my friend? How fast would she say the apple's moving? Well, from her point of view, not on the truck, off to the side, both of the speeds, both of the velocities would add together, the 15 meters per second and the 20 meters per second, making the apple appear to move 35 meters per second. So when both of the motions are in the same direction, they add together. So now let's say I turn around and I start throwing apples from the rear of the truck, backwards. I would still say that the apples are moving 15 meters per second from my way of looking at it, because that's how fast the apple's moving. But notice it's going in the opposite direction now as the way that the truck is moving. So my friend on the sidewalk over here, she's like, oh, okay, 20 meters per second to the left, 15 meters per second to the right. So it actually changes the problem a little bit, and it subtracts. So the 20 is going in one way, but the 15 is going the other, so you can see how that became negative for a total of 5 meters per second. So the apple would appear to go slower. In the example, we're really talking about two different people having two different frames of reference while trying to measure the same thing. So you can see how from two different points of view it can be different. Let's look at the next example. Imagine that you have somebody standing still. They're getting their picture taken. They caught a fish, so they're not moving. Relative to the ground, their speed would be 0 meters per second. You're not moving relative to the ground. But what if we backed up a whole lot to the sun? Okay. Since the Earth is orbiting the sun at 29,700 meters per second, an observer standing on the sun, ouch, that'd be hot, would say that you're moving 29,700 meters per second. So both are correct, 0 meters per second and 29,700 meters per second. It just depends on the frame of reference. So that's why when we're talking about motion, it's so important to think about the point of view or the frame of reference